Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you everyone for clicking in this video. So in this video we are going to learn about static fluid. I believe that you guys already read maybe somewhere. You already make a resume about static fluid in the previous meeting. So at least I hope you already read what is fluid, the definition, and also about mass density and hydrostatic pressure. So in this video we are going to review again what is fluid, especially static fluid, and also mass density, and finally at the end we will learn about hydrostatic pressure. Okay, enjoy the video. Before we start, maybe you already see this phenomena in our daily life, and I want to ask you a few questions. Which one much easier? A. Leave large rock in the water, or leave large rock on the ground? You can imagine maybe when you went to swim and you try to lift your friend, for example, in the water. For example, he or she has like 50 kilogram and you leave her or she in the water, compare to when you leave her or she on the ground. Which one do you think is much easier? Okay, another question. Why air balloon can be lifted? Have you wondered how a hot air balloon can rise into the sky? Yeah, it's using a fire, and but why? How it works? So the air balloon can be lifted. Okay, and last questions from me. What happens to an egg if we put in the fresh water, or what if in the salt water, or maybe in the sugar water? Have you tried? Have you experimented this? So I hope after this chapters from static fluid, you guys can relate these principles of fluid statics, and you will understand why this happens. Okay, let's start. The definition first. Definition. The definition of fluid statics. What is fluid? Fluid is a substance that can flow. Is divided into liquids and gases. So that's maybe somehow at the beginning, maybe some of you think fluid is, for example, water, yeah, something. But that's not only water only, but liquid, yes. Liquid um, can be water, oil, mercury, everything that can move. But not only liquid, gases can flow as well. So gases still part of fluid. Okay, there are two types of fluid. The first one is static, that everything is stationary, no fluid is moving. And the other one, we have dynamic, so the fluid is moving. If the fluid moving, then it will have speed. All right, so there will be v in dynamic. Okay, but in static, without velocity or speed, yeah, so it's rest stationary in the place. Yeah, statics no flow, and dynamics fluid is flowing. All right, what we have in static fluid? In static fluid, that the fluid that is stay in the place or not moving. And the example, yeah, you can imagine what? Water in glass, water in lake, maybe in front of you there is a glass with water. Now that is static fluid. So the fluid is stay, rest, or stationary inside a glass. Okay, so in static fluid here you will learn about mass density, pressure and hydrostatic pressure, and also U pipe. It's kind of like a tools to measure the density, usually like blood or oil. Yeah. Later we learn about U pipe and also Pascal's law, Archimedes law, cohesion and adhesion, and also symptoms of capillarity, and the last surface tension. So, but in this video we are going to learn about A and B, yeah, mass density until hydrostatic pressure only. Okay, what we have next? Okay, let's move to density. What is density? The density is defined as mass per unit volume, m per v, yeah, is a characteristic property of any pure substance. The mass density measures how heavy a unit volume of fluid is. Okay, for example, you know oil, right? For example, cooking oil and also water. Every kind of object in the world, in the earth, it has density. Let's compare between two liquids, oil and water. When you mix it together, when you pour oil into water, then you can imagine what will happen when oil mixed with water. It cannot be mixed, right? It separate. Oil will be on top of water. Why is that? We can say that the oil is less dense than the water, or we can say the water is much dense than the oil. Or yeah, let's say the water is much heavier, but heavy in here is heavy, the unit of volume, yeah, than the oil. That's why it cannot be mixed, because those liquid, water and oil, have different density. When you maybe you can find somewhere in the book or in the Google, the rho or the density of the oil is 800 kilogram per meter cubic, but for the water is 1000 kilogram per meter cubic. So much bigger, much dense the water than the oil. Yeah, that's why the water always below oil. Okay, so here the formula rho. Here rho, this is the symbol of rho, represents density, is equals to the delta mass, the total mass, divided total volume. Okay, yeah, this is the information. Rho as density kilogram per meter cubic, m as mass in kilogram, v as volume in meter cubic. The mass, this is the table of mass densities of some fluids. You can see mercury 13,600 kilogram per meter cubic, water at 4 degrees Celsius is 1000 kilogram per meter cubic, seawater 1025 kilogram per meter cubic, and etc. Usually we mostly we use three of this: mercury, water, and seawater, and sometimes oil. Okay, next, yeah. Okay, this is about practical. Because we cannot practice it right now because we are in the online session. I will show you a video, the song about mass, volume, and density. Let's watch this.
Every object on this earth, every substance that you see, can be described and measured by physical properties like hardness, color, or malleability, odor, length, or temperature, or these magic three. Mass, volume, density, three physical properties. Mass, volume, density. Hey everybody, my name's Mass. I'm the amounts of matter in a solid or a liquid or a gas. My unit is the kilogram. The more force it takes to move me, the more massive I am. And let's get this straight, mass is not the same as weight. I stay constant.
As for me, I change depending on gravity.
Mass, volume, density, three physical properties. Mass, volume, density.
I am volume, call me V. The space that something takes up, that's me. Tiny as a teardrop, large as the skies, or something in between. I'm a measure of size. Milliliters or cubic centimeters. Either way, I am 3D space. A cool way to find me. Drop a thing in water. How much water does it displace?
Mass, volume, density, three physical properties. Mass, volume,
And finally, density, I'm density. How tightly packed your molecules are, like people in a subway car. Are they close or are they far? Density, I'm density. Does something float in the air or sea? If the object has less density, it floats. Buoyancy.
Maybe I have buoyancy.
what's our connection? Excellent question.
We are related like a family.
If you know two of us, you can find the other.
D equals M divided by V. Yeah, D equals M divided by V. Mass, volume, density, three physical properties. Mass, volume, density.
Okay, how was the video? I hope you enjoyed the video. So, what did you get from the video? Mass, volume, density. You can find mass from scale. When, for example, when you weight your body on the scale, then you can find, for example, like 50 kilogram. That is the mass. You can try by your own using scale, then you can find the mass. And after that, the object you put inside glass beaker with scale here, put inside.
Volume, call me V. Tiny as a
Okay, starting in here, this position, this is the initial volume, and when you drop the object, it will the water will displace. Nah, the displacement or the change in volume is the volume of the object. So you can find volume of the object equals to sorry, the volume of the object is the volume of the object equals to final volume minus initial volume. Then you can find the volume of the object. And after that, when you already have mass and volume, then you can calculate using formula rho as mass per volume, then you can get the density. Okay, next, this is the example of mass density. You can read here, you have mass 100, the total mass of the glass and the fluid. Okay, what kind of fluid? This is based on the mass density as listed in the table. So you must find the density of the fluid, the mass. Okay, the mass of the glass and the fluid is 200 gram, and but if only the glass is 100, so the mass, so the mass of the fluid is 200 minus 100 gram, that is 100 gram. And for the volume is 150 milliliter, you change it to centimeter cubic. Okay, so the rho, how much is the rho? Rho equals mass divided volume. 100 divided 150 equals 0.667 gram per centimeter cubic. So equals 667 kilogram per meter cubic. Okay, from the table, where's the table? You can check how much is 667, sorry. How much? What is that? 667. What is 667? Nah, 667. Nah, it can be premium. Bensin ya, in Indonesia. Okay, yeah, it's premium. Okay, I think it's much easier, yeah. I think it's so easy. I mean, yeah, I think this is still easy, yeah. I hope you can catch the meaning of this, the mass density of fluid. What we have next? Okay, fluid mixture. When you mix more than one fluid, for example, like when you mix oil, cooking oil, and oil for a machine, for example, and the mass density of the mixture of those oil is rho equals rho 1 volume 1 plus rho 2 volume 2 divided volume total. Okay, that's the new density. What we have next? Mass density of fluid mixture example. For example, I have water 100 milli and mix with 300 milliliter of alcohol. We can assume the volume of the mixture is equal to 95% of the summation of the volume of its initial components. So we got here the information, the known data. Don't forget to change to meter cubic. And then row 1. Okay, this is from the table, yeah, from the table before. Row 1, that is water is 1000, and the density row 2 from alcohol is 290 kilogram per meter cubic. And this is the answer. You put the formula, put the numbers, and you calculate, and you got the result. That is 887 kilogram per meter cubic. Okay, that's all I think about mass density. Very easy, right? Do you have any question? You can write your question in the comment, yeah, after this. And next, we still have pressure and hydrostatic pressure. Pressure is defined as force per unit area. Okay, I have an object here inside the liquid, let's say water. An experimental observation said that a fluid exerts pressure in every direction. Uh, do you feel something in the air? You realize it or not, you are pressed by air in every direction. All of your direction, all of your skin touch the air. All of your skin is pressed by the air. That happened as well to object inside the liquid. That's why when you went to swim in the sea or in the swimming pool, getting deeper, you can try to remember when you swim, getting deeper, you will feel getting more pressure, isn't it? it will be much harder to breathe. Your your chest will be much yeah, will feel more pressure. That's why the diving has limited the depth of the sea. For example, like 100 meters of or something. When you use uh, of oxygen tube, you have limited deep, you have limited height. Don't work. That's because of the pressure. Yeah. In here, we want to know the pressure at the bottom of the pool at the depth of h below the surface. And in fluid statics, we always think about downward, the depth. The height in here is the depth, yeah. We think about downward as the positive direction. So the deeper you go, the greater the value of h. Okay. So in the beginning, we will have P as pressure is force per unit area. As you know that force can be mass times gravity, and from we change m in here from density, rho equals to m per v. Okay, you have P as force divided area, and you know force in here is mass times gravity. And in the previous, you already learned that rho is mass divided volume. So it can be moving. We move the position m as rho times volume. So that's why m here become rho volume gravity divided area. Area, you know area? When this is the object. I'm sorry, it's not really that good. The area is the area length and width. Length multiply width. And also next we have, when we mix the position, rho g volume per h, and volume as you know is meter cubic, right? And area is meter square. So you got, when you cancels out with other words here, then you can have 1 meters. This is h. So you have pressure in liquid is rho gh. We call it hydrostatic pressure. Okay, so you have pH or hydrostatic pressure is rho gh. Rho is the density. For example, the density of water is 1000. Gravity, yeah, we can round up to 10 meter per second square. And h for the height of the column liquid above the object from the surface, yeah, surface of the water. Okay, now this is for the other pictures in here. When we have more than one substance, in here we have 3 substances, for example air, water, and sediment. For example, we have what is it, something here below. How much pressure that the marine experience, that is the total pressure from water and sediment, yeah, and also from air as well. So that's why we have total pressure here. Total pressure at the position depth h from the surface becomes, okay, total pressure, this is air pressure, plus rho GH. I have four objects here. I have four different tubes here, A, B, C, D, at the same height from below and from above as well. The question is, between point A, B, C, D, which one has the highest hydrostatic pressure? Which one has the highest hydrostatic pressure? Remember, the hydrostatic pressure depends on rho GH. Remember, hydrostatic pressure depends on rho, the density, and from A, B, C, D is those have same density, water, and then the gravity as well. Let's round up to 10 meter per second square, and also the H. So, which one has the highest hydrostatic pressure? 1, 2, 3. Yeah, all has the same hydrostatic pressure. All of the condition A, B, C, D, same hydrostatic pressure. Why? Yeah, rho, G, and H, all of these points same. So the hydrostatic pressure will be same. Let's predict which hole has the longest distance of water. Point A, B, or C. Maybe you can try this as well. You can have a bottle of water and you make a hole, 3 different positions, and you can see how long the distance of water come out from the glass, and explain why. Okay, A, B, or C, which one has the longest distance of water? Yes, it's C. Yeah, C has the longest distance because point C is in the deepest point, meaning that it has the greatest hydrostatic pressure. Remember, yeah, rho GH. Oh, we have H in here because the C is much deeper than A and B. So yeah, C will be the highest point, will be the highest or the greatest hydrostatic pressure. Next. Okay, this is the example. You are asked to find the hydrostatic pressure and the total pressure. Well, hydrostatic pressure is only rho GH, but total hydrostatic pressure plus the air pressure. So total pressure equals air pressure plus hydrostatic pressure. You put the information, then you calculate, then you got the result. Okay. Right, finally we are in the end of the video. Thank you so much for clicking in this video, and please comment maybe when you have any questions, or maybe just give reaction. That's okay. Thank you so much again, and see you in the next video or maybe in the next meeting. Assalamualaikum warahmatullahi wabarakatuh. Thank you.